Hello and welcome to Start Your Infrastructure as Code, IaC journey with FlashStack. So today's webinar is sponsored by Pure Storage and Cisco and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. We won't have a dedicated Q&A session at the end of this presentation, but our speakers and some other experts are standing by to answer all your questions in the chat. And with that in mind, this event will last about a half an hour, so get your questions in as soon as you have them. Don't wait for the end because we'll be wrapping up. The Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh is going to fix most audio, video, and slide advancement issues, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. In your handout section of the webinar control panel, you'll also find that we're offering a lot of useful resources. We've got links for FlashStack, for Pure Storage, and a Pure Test Driver. There are also links to Cisco's DevNet, the Cisco Validated Design Navigator, and a Cisco UCS Solution GitHub repository. You'll also find in there links to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's great printed resources on technology topics, as well as a link to the ATM Event Center, which has our calendar of upcoming events. I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webcast, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handouts section. Just scroll to the bottom and you'll find the prize terms and conditions link there. And finally, one of the best benefits of an event like this is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the great one, and contact that prize winner. And with that, let's get to today's fantastic content. So it's my pleasure to introduce you to our presenters today. We have Joe Hughes, who's Senior Solutions Architect with Pure Storage, and Chris O'Brien, Technical Marketing Director at Cisco. So I'm going to turn things over.
Thank you, Scott, for having us today. I'd like to welcome everybody to Start Your Infrastructure as Code journey with FlashStack. My name is Chris O'Brien. I'm a Technical Marketing Director here at Cisco Systems, and I'm accompanied by my partner in crime, Joe Hughes. I've been with Cisco for over 20 years, been supporting our validated design program for nearly as long. And I've been part of the FlashStack program since its inception here at Cisco. So thank you for joining us. And Joe, can you introduce yourself?
Sure thing. Howdy, y'all. I'm Joe Hughes. I'm currently a Senior Solutions Architect at Pure Storage, focused on the FlashStack platform and all things automation and integration. I actually come out of about 20 years in IT, primarily in the customer space, before moving over to the vendor side. And I've been a longtime consumer of the Cisco Validated Designs, so it's particularly cool for me to actually be involved in the process that helped me so much when I was actually in the field. So a lot of my background is as an infrastructure architect, a data center engineer, and being responsible for then automating all of those nerd knobs that I loved playing around with in the field. So as we start this off, we want to make sure that everybody understands what it is we're talking about with our platform here for FlashStack. So we're going to start with leveraging Cisco UCS Compute. In this image here, we've got a new X Series chassis. So we're going to be talking about a lot of the new features and functionality that comes with the new components and the new hardware, especially with the integration that we get along with this. Behind this UCS storage, we're going to back it with some behind this UCS compute platform, we're going to back this with some Pure Storage that we've got here. So we're showing a flash array or a flash blade, also with the benefits of Evergreen. This is going to deal with any upgrades that we need along the way for our storage platform. For connectivity here, really, it's kind of a choose your own adventure, right? What we have with FlashStack has the capabilities of doing traditional Ethernet or traditional fiber channel connectivity here. So we're going to have Nexus or MDS, or you have the capabilities of consuming both between UCS and Pure Storage. So really, this is kind of, design what it is that you need for your own capabilities inside of your data center, and we can build a FlashStack, right? We get this reference architecture type of build that gives you flexibility to consume the platform however you need. The real power that comes in for a lot of this comes from the fact that this is a stateless architecture. That means that both on the UCS compute side as well as the pure storage side, all of this is a logical configuration that can get laid down to the specific hardware. Within the UCS, we're talking about the fact that our servers are all deployed via a service profile. That means things for the identity of the server, such as a MAC, a WWN, the UUIDs, the boot policies, all the firmware, the specific BIOS versions, and everything are all contained within a profile where an instance of that profile gets deployed down to our hardware itself. The flash array works in a very similar fashion where all of this configuration for the flash array is defined in the software, right? Everything around the array itself, as well as everything around the hosts that are connected to it for the MACs, WWNs, IQNs, IPs, are all in this logical configuration deployed via software. For customers, what this really means is that they have the capabilities to architect once and innovate continuously. That means that customers that deployed on the very first iterations of UCS hardware or flash array storage could upgrade throughout this entire process, with this being a non-interruptive upgrade. So whether they needed to scale resources independently on the compute side or for storage, whether they needed better performance or they needed better capacity, all of this was completely non-disruptive, where the initial architecture that was deployed could just be expanded without it being downtime or without it being any sort of drastic maintenance event to re-architect an entire environment and deploy from scratch. So, Chris, what about what else do we get from this?
Yeah, Joe, I think, this is just a snapshot in time. This program's been going on. The success has been there, for the two companies and for our customers, they get to take advantage of this architecture. But, just in 2021, 2022, we've introduced our new M6 platforms from a compute perspective. So you get to consume not only our M6 platform on our existing 5108 chassis, but our X series chassis as well. So the X210C nodes. But also what's not even captured here is the fact that you get to take advantage of Cisco's fabric. So the latest and greatest innovations from a fabric perspective in terms of, SAN connectivity, 32 gig fiber channel, ACI capabilities with our, application-centric infrastructure. So the point is the FlashStack allows you to innovate and consume this technology seamlessly over the course of time, not just from a compute and storage perspective, but from a fabric perspective. So, we really feel it's an architect once, innovate constantly, consume at your own comfort level, I guess. So if you go to the next slide, the program that we built, the Cisco Validated Design program, the average validated design, which is a fully documented best practice between Pure and Cisco, takes, anywhere from 4 to 6 months really to complete. And some of them take longer. If you have a full, metro cluster design, hybrid cloud type models, it might be a little bit more work. There's more engineering effort. But both companies fully plan the design, get feedback from our customers. We do full end-to-end validation, and we capture them traditionally, and I'll leave that a term to Joe to address later, traditionally in a PDF format in terms of documentation. But what that's really done is allowed our customers to consume our technology safely with minimized risk and accelerate time to value, in their data center and wherever they happen to be positioning Cisco and Pure FlashStack. So if you go to the next slide.
Yeah, I will say, so as a consumer of the Cisco Validated Designs in the past on a FlashStack platform, I really loved the capabilities that were brought to the customer space by just having this ease of deployment out of the box that we had, right? Everything from spinning up the network from out of the box to initial configuration of IP addresses, loading all the firmware for the network for the UCS, taking a pure array from, initial config to actually get all these things up and running and getting it to the point of having a workload that's actually running inside of this environment and having performance metrics that we know what it is we're actually trying to attain with this was absolutely fantastic on the customer side. To your point, Chris, the de-risking of all of this by understanding that all of these components are tested, we know which specific versions of all of this, actually work together in a full deployment end to end. And whether it was an environment where I was consuming things, on VMware or as bare metal SQL servers running on Windows, or even deploying my first SAP HANA environment as a customer when I'd never seen it before, I was only able to do this because of the fact that there was such rich documentation through the entire Cisco Validated Design on this. So whatever platform it is that you're looking to consume and whatever workloads you're looking to run inside of your environment, we probably have one of our more than 40 CVDs that covers the base of getting this inside of your environment and building this out from scratch. Now, we understand what FlashStack is, right? We understand all the components that go into the platform. We understand the Cisco Validated Design, but now the next step of what we're discussing is infrastructure as code, right? So what is it that we're actually talking about here? So with infrastructure as code, we're really trying to look at the management of infrastructure, and we're trying to systematically provision all of these resources with code. A lot of what this really means is that instead of doing manual steps and instead of even following the CVDs of the past where we were clicking through all of the screens and making sure we clicked the right checkboxes or the right radio buttons and setting everything exactly where it needed to be, we're doing all of this through a configuration model now, where these live inside of essentially text files, right? Config files that we're able to hold and deploy to a system and have another orchestration layer that takes care of this for us. Now, there's going to be differing models for infrastructure as code, right? There's the declarative versus imperative. And some of this even mirrors what we had traditionally in the past for what everybody thought of automating, which was typically scripting an environment versus infrastructure as code. When we think of infrastructure as code, primarily most people are going to be talking about a declarative model. This is where we actually tell the system, we want you to look like this. This is my desired state, and I want you to make this configuration happen. And the system will take care of running all the checks and making all the changes that it needs to. Versus an imperative model, which is more along the lines of what we did in the past with automation via scripting, which meant that you actually had to be responsible for all of the steps in the right order to make these configurations happen. We really want to start driving a lot of things more to a declarative model because the platform and the tooling and the orchestration will take care of getting us to these results, which we want to be idempotent. And funny enough, I've had people listen to this presentation, including a couple of my marketing folks, and they wanted to make sure that I was not just making up words for this slide. This idempotent result that we're aiming for here is actually a true word. This is a term that we're aiming for. What this means is that whether I run this code one time or I run it 1,000 times, I want to have the same result at the end of this, right? So between the configuration and the orchestration that's handling all of this, we want to make sure that we have consistent results that come out the other side. We're also dealing with now using version control for all of our configuration files, right? This is getting us a little bit more into the mindset of running our infrastructure the same way that a developer is going to be deploying code, where we have configurations that are set at a specific point in time to attain a specific result that we want. But then as we make changes, we have the capabilities of testing this. We have the capabilities of having an automated process that rolls this out to our environment. So really what we want to do is we want to have these capabilities of developing and releasing changes for our environment faster, but having higher confidence in our deployments, right? So the real benefits that we're actually getting out of infrastructure as code, which have been fantastic results we've even seen between the Pure and the Cisco teams as it relates to the Cisco Validated Designs, are things like speed, right? So it's quicker to get to having an environment that's spun up to the exact configuration that we want. It's easier for us to do this because now every time we tweak an environment or go for a different result, it's going to be an iterative change typically based on all the work that we've done in the past. We also have an easier time of having a metric for what our performance actually is. And it's even simpler to get people to be able to deploy this because if people can understand what is typically a more human readable form of these configuration files and the tooling that we're using to run this orchestration to deploy our environments, it's a lot easier than folks had the uplift of becoming a subject matter expert on all things when it related to the UCS compute layer and fiber channel and Ethernet storage and the storage underlying everything itself, right? So all the connectivity that we had within the fabric as well as the UCS compute, people had a lot more difficult time to get up to speed on this when they were working with the interfaces rather than having this layer in between that's handling this by just dealing with the configuration files itself and defining what we want our environment to look like. Also, based on using tools that have this idempotent result, right? We get these consistent results and we get an infrastructure that comes out the other side that looks exactly what we want it to be every time. We're also minimizing the risk. So this is just elevating the things that were already being done with our validated design of having this end-to-end deployment where we know how this thing works, all the components that go into it, all the specific versions and everything, and we can get our consistent performance results at the end we minimize the risk even further because rather than somebody having to click through 300 pages of a validated design and ensure that they didn't miss a button somewhere in between here, it's all captured in the configuration. You know exactly what gets deployed to your environment. And we can reduce errors because of the fact that anyone can look at this configuration to see exactly what was deployed to our environment. And this will stay the case as time goes on. As changes are made, since we're doing this in version control, people can see what happens over time to versions of our configuration to see changes that are actually made inside of our environment. All of this leads to increased efficiency because, especially for the Pure and the Cisco team, we've seen how much quicker we can actually get to deploy an environment from scratch based on having this configuration in here instead of doing manual deployments. And in the end, this leads to just cost savings. For us, it's been efficiency for the amount of time that it takes for engineers to deploy these environments, for someone else to come in and do the validation on these, or for us to be able to actually get workloads on top of this infrastructure and get to the real meat of what it is we're trying to do with these validated designs, which is really solving a customer use case that we have for this. But at the same time, it's also just going to be, again, reduced risk and easier to manage our infrastructure over time. So all of these cost savings are over the lifetime of our environments as we're starting to deploy via infrastructure as code. And then here are two different concepts that we want to look at, primarily just because of the tools that are going to go into this. We're going to be looking at orchestration versus configuration management here. Now, when we start talking about orchestration management, this is really going to be a lot of our process of automating and coordinating everything that goes into the process and these workflows that actually get implemented on our servers. This is going to be provisioning our requested resources, making sure that we have all the components and everything that we need in place. And this is going to be also how we're going to scale our environment. As we have this process of automation handled, as we decide we need to provision more resources, or as we decide that we are bringing new capabilities and new hardware into our environment, the orchestration is going to take care of putting that initial configuration and putting everything into our design, into our environment as it's specified in the design. And then typically we're going to have a bit of a separation here, and that's going to be the configuration management, which is where we actually get to the configuration and maintenance of, say, our workloads and things going forward from there. So we're going to deal with actually putting down all of the configuration for what we need to run our environments, all the specific changes that we're going to have, which are going to be more minor incremental things that are going to handle the workloads and the actual life cycle of our hypervisors and our operating systems going forward. This is also where it's easier for us to document changes and maintain consistency because we're going to be making these minor incremental changes as we go forward with this. So the entire cluster can be, configuration files that can be deployed across the entire environment, and it's easier to implement all of these things. And it's also easier to debug because if an issue arises on these minor incremental changes, we can see where these consistency fluctuations happen and come back to these configurations to see where these changes were made over time. And then as we talk about maintenance and reconfiguration, this is just going to be that, as we go forward and as we have anything that needs to potentially be swapped out in our environment, whether that's on the hardware side or as we run into any particular issues with specific versions of software that are running inside of our environment, configuration management is going to handle how it is that we do all of this and how we do these reconfigurations during the actual life cycle and operations of our environments. So now that we kind of understand the process of the Cisco Validated Design running on the FlashStack platform, and we understand at least what it is we're talking about at a concept for infrastructure as code, the process that actually got us to doing infrastructure as code for the validated designs started off with the first iteration for FlashStack being OpenShift. And this validated design was only 76 pages long, which was really interesting to me because of the fact that it was essentially a cloud native architecture. It was an architecture where the entire environment itself for all of the infrastructure and these workloads was really meant to be automated end to end. So it was very easy to come up with a validated design that really just kind of described to folks how to use the infrastructure as code to deploy the environments. But then when we look at our traditional workloads, we look at things like vSphere or a validated design that was actually the same base of vSphere 7.0 update 2 and then layering Citrix on top of it. We jumped up to 350 pages for vSphere and over 500 pages for Citrix. Now, admittedly, in that validated design for Citrix, there's 40 to 50 pages in here that are specifically just performance metrics that are inside of here. But still, if we look at that and even said that was 450 pages, that was primarily about the infrastructure and getting it up and running, that's quite a lift, right? And that's a lot of investment that somebody has in following this guide and making sure that they can get all of these configurations set properly for this environment. When you look at this from the infrastructure as code, it becomes a little bit easier to manage because of the fact that at this point, we're actually taking a lot of the manual steps out of the process, right? We're putting all of this into the configuration files, and you're able to take at least our base configuration, modify variables to match with your naming standards that you need, your IP addressing, your descriptions, or any differences that you have for specific VLANs or any other structures that you have for your virtual environment, your networking environment, or your standards for how things are named inside of this. And by just modifying these configuration files that hold variables, you can just run this code inside of your environment, and it becomes a very minimal lift for somebody to actually get a deployment up and running inside of your environment. I like to pitch that FlashStack.
Hey, Joe,
Sure.
I'm sorry to interrupt. I just had a thought while you were talking is,
Yeah.
the beauty of this, the combo of the infrastructure as code and the CVD is that you still have that reference architecture and the reference to go back, like, what is this code actually trying to do? You can go and see and reference. So, CVDs sometimes aren't read end to end, but actually more of a reference that people use over the course of time. So just wanted to add that in as well.
I have actually recently used them to be a pitch for people to start learning infrastructure as code, right? I always try and get people to take something that they know and stretch themselves to learn something a little bit more. And especially if you can teach yourself by taking advantage of some of these tools or some of these resources that vendors have available, there's absolutely no reason not to. So one of the things I like to tell people is if they understand any bit of this, whether it's the UCS, the fabric that's inside of here, the Pure Storage, or if they can even just look at our logical designs that are used for this to see how the environment gets built and look at our configuration of what's the end result, they can start reading this infrastructure as code and just understand how it is that we're consuming Ansible and Terraform as just an easy, quick get started guide, because they know exactly what the result is that we're getting out of this, and they can follow the guide to just understand how we got there.
Makes sense. Yep.
So I again, to the point of leveraging the CVDs, this is one of the biggest reasons that I want people to try and start their infrastructure as code journey with FlashStack, right? It's best in class performance on all of this. It's best in class products that we have across all of this. I've been a longtime consumer, so I absolutely love all of the things within the Cisco portfolio. I absolutely love Pure Storage, which is part of why I'm here working on this. But it's just the capabilities that we have of all of these platforms, of all these components within this platform, to be able to automate end to end, to be able to swap in and out all these components as we have new upgrades to give us new features and new functionality and new speeds and feeds and all of this stuff, right? Being able to have infrastructure as code that can handle this environment, or if you've never done any of this before, taking something like a Cisco Validated Design to where you can use our automation that we've already built to build an entire vSphere environment where somebody can at least understand the basic concept of what it is we're building out of the box for this. I think this is one of the best platforms to start with this, because we've done all the heavy lifting to get it to this point of this validated design with this known performance metric that you're getting out of this. And if you can learn these concepts, especially for IT departments that struggle on getting on board with using the same tooling for a lot of this, you now understand how you can automate your compute, your fabric, and your storage environment. If you can take these concepts and this methodology of how to do this and spread it across your entire data center or even your hybrid cloud, it's a win for your entire organization. So Chris, why don't you tell us what all we've got under the Intersight Cloud Operations platform here?
Sure, and I think, to your point, that FlashStack can be part, and probably part of a lot of people's current hybrid cloud infrastructure. And what Cisco's brought to the table over the past few years is Cisco Intersight, and it is a cloud operation model. So it's a SaaS-based platform. There are air-gapped and tethered versions, but the point is with Cisco Intersight, you can manage at scale, at cloud scale, from edge to core to cloud, and all you can see the list of use cases that we've support for in terms of our validated designs. And this is just a sampling. We have plenty of customers that are creative and doing their own type of workloads. These are the ones that we're covering here, VSI, hybrid cloud, whatever. But the components, and you can see the X series platform, the B series, the C series, all fully managed, of course, by Cisco Intersight and available for you to use. But then what's happened is Pure has taken the steps to really do a lot of engineering work and collaboration with Cisco to start integrating with Cisco at a number of different levels from a storage perspective in terms of both Kubernetes-based storage with Portworx, with the FlashArray platform, FlashBlade, and that extends itself to FlashStack itself. So in terms of traditional element management, we've kind of broken that model with Intersight and allow you to work at a different scale, a public cloud scale.
Absolutely. And as we come to discussing what specifically Intersight gives us for the benefit of running infrastructure as code, the two big things I want to highlight here are the two top left and right corners inside of this big box here, right? We have the Intersight Cloud Orchestrator, and then we have the Intersight service for HashiCorp Terraform. Cisco saw just the huge benefit that could be brought to bringing automation to the on-prem data centers, but still having this delivered in the cloud model. So as new features and functionality exist within Intersight, just because it's a SaaS platform, by literally logging out of Intersight and logging back into it, you could actually be running a new version of the code inside of your browser that's actually connecting to Intersight. So you may have new features and functionality that comes in just every time you log into the platform. But specifically with some components that are inside of here, right? Anybody who's using HashiCorp Terraform, you've got native functionality inside of here to be able to connect to Terraform Cloud, to be able to just even manage your state files inside of the HashiCorp Terraform Cloud, which is fantastic for just not having those resources there locally. But any new capabilities that come into the HashiCorp Terraform platform are now going to be consumable within Intersight. And then Intersight Cloud Orchestrator itself, I just absolutely love this tool. And even for customers that are running some level of automation inside of their environment, even if it's things like Bash scripts or PowerShell scripts or Python scripts inside of your environment, you don't have to completely abandon all of this to go infrastructure as code. You can put these components that you have into the Intersight Cloud Orchestrator and actually consume them as they are now, as you decide to migrate over. If you're going to run Ansible or Terraform, or even if you're going to connect some workflows like we're going to talk in a little bit, any of this that you've already invested in is still consumable within Intersight without making drastic changes to this. So, Chris, why don't you cover some Intersight fundamentals for us?
Yeah, I think, the key point is that Intersight being a service really allows you to consume it how you want to work. And I think that's the point I like to take away for everybody here is that if you invest in Cisco and Pure and FlashStack, you can take advantage of our RESTful APIs and Cisco Intersight, work the way you want to through Ansible, through Terraform, through PowerShell, whatever it is. So your operational model doesn't need to change to support FlashStack, right? You can use it through Intersight, and I mentioned it briefly before. Pure invested in creating a device connector, defining its storage within Intersight, making tasks, making workflows, making Pure Storage accessible through Intersight to manage, to orchestrate, to automate, and deliver through code. Was a big step for us. They were the first partner of ours to actually see the vision that we were trying to portray with Intersight, invest, and they take the journey with us. And the result is a stack that you can manage essentially through a single point. So, Joe, why don't you talk a little bit about our cloud orchestrator?
Yeah, one point I want to make here real quick about the Intersight itself, like just one of the things that I absolutely loved on the customer side was getting the functionality of just having the tunneled KVM for my UCS blades inside of my environment without being VPN'd in. And then seeing with the device connector and having the integration with both VMware and Pure Storage, the fact that I can actually run workflows inside of my environment to manage my on-prem infrastructure through this cloud platform where I don't have to manage any of the functionality. It's all just inherent by using Intersight. It's absolutely fantastic. So as we start talking about this, right, this is one of the things I was just mentioning is our workflows that we have. Intersight Cloud Orchestrator makes it easy for us to handle a lot of orchestration and automation in the hybrid cloud. So whether this is our on-prem environments or public cloud environments, we have the capabilities of doing essentially some low-code functionality here, right? We can drag and drop things to create workflows that we can make consumable by other users of the Intersight platform so that they do not have to be subject matter experts on these things. You can set up some of these workflows so that somebody can just enter a specific name or a tag or some identifying information about what it is they need for a specific environment. And these workflows will run. without anybody needing to understand anything other than the instructions of how you've configured this workflow itself. They don't need to understand any of the underlying, UCS fabric or storage or even virtualization portions of this beyond just the details they need to figure out and put into these workflows themselves. So Chris, why don't you wrap up with where people can find some information about this?
Sure. So, we have on Cisco.com, we have a CVD navigator. You can see the links down below. So hopefully you get a copy of this or take a screenshot. We also have Cisco DevNet. So all of the infrastructure as code we're making available in our own UCS solution GitHub repository. And then we also expose it through Cisco DevNet and our code exchange. So as we develop different playbooks or plans, what have you, we'll make those available based on our CVD efforts, based on the experts here at Cisco and Pure, and we'll have different FlashStack repositories. So we hope to grow and continue to grow this library for people to leverage moving forward. Yeah.
Absolutely. One additional plug I love to give DevNet, honestly, like Cisco has made one of the most drastic investments of any vendor out there for building the infrastructure for this and trying to empower folks to become better at automating any portion of their network that's out there. And if you're unaware of it, go check out Cisco DevNet for the sandboxes. You can actually reserve to get physical hardware that you get a hands-on lab style module that you can walk through a configuration end to end for an actual use case against this hardware. So if you've never played with the Cisco UCS X series before, you can go reserve time inside of a sandbox and actually get access to that. Within Pure as well, if you want to test any of this functionality, or if you want to be able to test any of your code against an environment that we have, check out Pure Test Drive or reach out to your account team to get access to that so that you can actually get a virtual instance where you can test some of your automation code against these environments as well. If anybody has any questions, we will be hanging around in the chat. Otherwise, thank you. Chris, I don't know if you have any last points to make.
No, just it's a real honor presenting with you, Joe. Thanks for everybody
Awesome.
attending.
Thanks, Chris. All right. Thank you all. We'll hang out in the chat. Otherwise, we will see you all for the next webinar. Appreciate it.
Okay, and as Joe mentioned, they are hanging out here in chat for the last minute or so of the presentation. So if you did have a question that you didn't ask, this is your last chance to get it into the console. Joe Hughes, Chris O'Brien, thanks for putting together that really informative presentation today about infrastructure as code on FlashStack. And before we wrap up, we do have one more piece of business. It's the $300 Amazon gift card prize drawing. And the winner of that gift card is Mark Girk from Nebraska. Congratulations to Mark. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Pure Storage and Cisco for making this event possible. And thanks as always for attending and for your great questions. That's going to conclude today's event. Have a great rest of your day.